Hello and welcome to your first authentic decision. The goal of this presentation is a quick intro to the concept of authentication, authorization, the like, and how you as a developer who's been given a task to add authentication to an app, how you can get started, where to begin, what you need to know. So let's get started. Your product owner one day comes to you and says, make my product have a login. So like any good developer, you log on to Stack Overflow and see what people are talking about. You'll quickly come into some concepts like, what is authentication and authorization? What is OAuth 2 and OIDC? Where does Keycloak fit into all of this? And how do I pick the right flows to use for my apps? So what we're going to cover is a very high level intro to these concepts, a set of recommendations based on your app's infrastructure, and some links and resources that we found useful. This isn't meant to be like a hard technical introduction, it's more of a high level. So let's get started. Authentication versus authorization. Despite the fact that the names sound similar and it's easy to mix them up. Authentication is used to verify that users really are who they represent themselves to be, while authorization is used to grant the user permissions to access different levels of information and to perform specific functions depending on the rules that have been established for different types of users. A good way to think of this is an ID card versus a key to a room as an analogy. What problems are we trying to solve with OIDC? Well, firstly, your app no longer needs to manage a user's credentials. In the old days, when you wanted a login functionality on your website, your users would have to log in and their password and username would be stored in your database. That's no longer the case with OIDC. Secondly, because your user never exposes their credentials to the app they're logging into, it's more secure for them as well. An added advantage of outsourcing this login functionality to another service is that subject matter experts handle the login process, meaning they specialize in these identity and login flows, which significantly reduces the chance of human error exposing these credentials. The next concept of interest is the OAuth 2 flow. OAuth 2 is a standard that defines the best practice for integrating an app, or client, with a trusted identity provider, or IDP. For example, IDER is a trusted identity provider in the BC Public Service. A user is redirected from the client site to an authentication server. There, they enter their credentials and are redirected back to a client with an access token in tow. That access token can now be submitted with a resource request, and once the token is verified as valid, the resource is returned. Notice that the user never submitted their credentials to the client, only to the OAuth server. OpenID Connect is just an extra wrapper on the OAuth 2 standard. It allows an ID token to be passed along with those authorization tokens mentioned before, including things like GUID, name, profile photo, stuff like that. Um, you can actually fake an OIDC flow using only OAuth 2, but it's just simpler to do so with OIDC. Because OIDC is an extension of OAuth 2, OIDC can do everything OAuth 2 can. So here's an example of that ID token being passed back during an OpenID authentication, whereas with OAuth 2, you can pass it back as a specific key. We've gotten some of the basic concepts out of the way, which means now we can get to the decision making. The important thing to realize is that standard doesn't mean unique. For example, there's no single best way to build an app. What kind of database do you use? Whether or not there's a backend, what tech stack or language to code in, those are all decisions that have to be made based on your business needs. So why would you expect there to be a single best authentication flow for all of these different types of apps? This is where the CSS app users will have to start making decisions when using the CSS app to create an integration. We are going to cover 3 common use cases here. Question 1, do you have a backend? If not, you'll need to use a public client, ideally with a PKCE flow. When the browser talks directly to the authentication server, or keycloak in this case, the browser can't securely store the secrets necessary for a confidential flow. Proof key code exchange can help mitigate these risks by preventing malicious sites from stealing your tokens. A useful video discussing the RFC is included at the bottom here. However, what if you do have a backend? In this case, a confidential client architecture is possible. Here we'll look at the authorization code flow and the client credential flow. As you can see, the front end talks to your backend server. That backend server is able to hold a client secret and keep it secure from both the browser and the internet. That server then talks to the authentication server, or keycloak. Finally, do you need machine to machine? Client credential flow cuts out the squishy humans and lets computers talk machine to machine. Note this is OAuth 2 only, there's no OIDC in this process. It's useful for things like cron jobs that require credentials to run. Note that there's no action, there's no user input into this flow. Now that you've picked your authentication flow you'll be using, the next question is, what library do you use? Most logic these days is handled by libraries. Very, very few people are going to code up their authentication flow on their own. Luckily for you, we've compiled a list of useful libraries for different tech stacks and different authentication flows. Note you'll want to check that whatever flow you use, the library supports it, especially if you're taking a library that's not in this list, one we haven't looked at yet. This concludes our introduction to authentication flows. Hopefully, you as a developer now have a better idea of where to start when implementing login functionality in your application. Further reading and links to our library lists are included below.